Hello everyone and welcome in this very first and complete tutorial concerning the pop fluid solver. So yeah, this tutorial is fully interactive with a mouse. You can obviously use MediaPipe or Kinect or whatever, or audio to drive the fluid simulation we can see on the right. If I move my mouse up, we can see that we push a fluid in this box. So in order to get the first, I'm running on the 2025 31760 build, and you need to get my pop fluid solver on Patreon. So these are the requirements. I didn't test everything on macOS, but some of the users created a GLSL code you have to copy and paste in one node in order to use it, and apparently it's working pretty good. So maybe it's working. Anyway, so yeah, we have like summary of what is pop fluid solver in terms of techniques. A quick start that we're gonna see together, and what's included inside. And here we can find all the different files. So let's start from scratch. First, once you downloaded the files, there is two main files: the voxel grid init and obviously the pop fluid solver. Okay. So once you drop them in the project, they should be referenced, because here in the voxel grid init there is the pop fluid solver comp that you have to drop, and same here for the voxel the pop fluid solver, you have to drag and drop this here. They have to be both referenced. For now, nothing is happening because this represent, when I do this, we link the two systems. This system is made to set up the space where the fluid velocity is gonna be calculated, processed. And here is just how, the calculations themselves. And this represents a feedback loop. Internally, there is a feedback loop. So here we see that we have a few parameters like init start. If I init, I see like kind of a box of points appearing. It's a voxel system I created. So we're gonna first use a keyboard in chop with the keys 0 and 1 in order to manage quicker the grid init like this. So if I press 0, I init. If I press 1, I will start the simulation. Anyway, we see that we can play with some parameters like resolution, but we don't see the effect. We need to or init or restart the system to see the changes we made here, like this. So I'm just gonna do something quick. I pause the video. Okay, I wanted to add this little interaction display created by Electronaut. Super cool system. Anyway, when we do modifications here, we have to restart the system. So let's go back to a resolution of 32. Press 1 or 0. And we can see that also we can set the size of our voxel system. For now, we're gonna stay at 111. We're not gonna play a lot with the different parameters of voxel grid init and pop fluid solver. We're gonna, in this tutorial, approach the system in a input-output way in terms of big behavior, and then later we're gonna go into details in the next tutorial. So what I want to do now is to create a sphere. A point generator, sorry, with a sphere of radius 0.15. Okay, we're gonna push the number of points to 30k, and we're gonna put this in, because we see that here it's called geometry, but it's the geometry you want to fluidify. Here is the voxel system and forces, and here is forces and geometry. these two inputs are mandatory for the system to work. So if I reset, I see my sphere, but input attributes forces not found, attribute forces not found. This input here absolutely needs two attributes. So the first is forces in 3 dimensions, so flat 3, and it's not written here, but it needs another attribute called temp. And we see that when we add these two parameters, there is no error anymore. Perfect. What I want to do is when I move the sphere, I want the sphere to propulse itself to behave like in a liquid way. So what I'm gonna do this, add the null here, press D with the operator selected, or press here display. Here we're gonna split in two, and here geometry viewer. What I'm gonna do also, just for visualization, it's not something we're gonna render, but create a box connected to a geo, choose a wireframe material and apply it on the geo, and here we're gonna choose topology wireframe. So we see that sorry, our sphere fit in the voxel gradient, the voxel system. But if we do this, oops, I'm stupid, sorry. I want the size of this to reference it on the size of the box. So when I move this, I see what's happening in terms of, see? Like this. Like this. We see that it's deforming the box because we can't, the sphere, sorry. Because the sphere can't go out of the voxel system. So this tool here, this box we created, allows us to visualize the space we're gonna work in. Okay, so I'm gonna make the sphere move with a transform, create a noise chop. Here in common, enable the time slice, and in the channel write TR XYZ for translation X, translation on Y, translation on Z. We can change the seed, we can increase the period, and the amplitude like this. And let's reference it here. So yeah, we see that now the sphere is moving, but here nothing is really happening. It's because it's as I said, it's a feedback loop. So if we don't initialize every time again the system, reset it, we're not gonna actualize. There is a solution, which is to here enable particles live. Doing this, the system actualizes the initial position. So the particles are born and die every 2 seconds. Now we still see that it's not behaving in a fluid way. So we have this input here called forces geometry. What it does, let's stop the transform. What it does is that, let's say that we copy paste this and put it here. You can input a geometry, and if this geometry, let's display it. If this geometry is moving, it's gonna apply forces on the first input. Let's choose another shape so we're gonna understand a bit more. Let's choose, I don't know, it's super big, but like this. So we see that this is the first input that is behaving in a fluid way, and this is just like, I don't know, we're not gonna call it a collider, but it's creating forces. So it works on the translation, but also on the rotation. We see that the adaptive homing is boring. We see? Super interesting. Anyway, so any kind of movement in this third input gonna make the first one behave in a fluid way. I'm gonna delete this example, and now I'm gonna just connect this here. So now the sphere, by its own space displacement, is making itself behave in a fluid way. Nice. The thing is that here, in this third input, the more points you will have in input, the more forces you will have. But also the more points you will have, the more calculations you will have. And we don't really need a big amount of points. Because here we have only 30k, but if we want 1 million, we don't want 1 million of calculations, let's say, on this input. So we're gonna do a delete, but first, to have a clean network, I'm gonna select the transform, drag and drop it here, and now connect a delete pop. In the delete, I'm gonna go in the scene page and enable this, and scene out range enable, and I'm gonna go to the 1000. What does that mean? It means that we can have a big amount of points here. We here only gonna have 1000 points. So we can connect this here, and we're gonna increase the first, let's say, to 100k. Every time you modify the number of points or the structure of the topology, let's say, of the first input, you have to reset the system. So you see now that here we still have 1k, 1000, but here we increased the number of points. Instead of adding more points to have more forces, there is a geometry forces multiplier here. So if we put, for example, 10, it's way more interesting, maybe too much, honestly. But we can also, here it's pushing in the direction. Look, if we display the sphere, it's pushing in the direction, but we can also create like propulsion, but by adding minus. So the sphere is propulsing itself. Anyway, let's go back to 5. So we saw in this visual that we don't only have this sphere pushing itself, we also have a lot of different particles around that we're gonna call particles environment particles. Let's create these environment particles. You can save the project just in case, it's always better. And here, point generator, we're gonna create a box, and we want the box to fill all these points, to fill the space. So we're gonna go to voxel grid init and take the size, the size, and reference it here. But I don't want the size to be, let's do it. Let's merge this with this way. Reset it. I don't want the points to be exactly on the bounds, because it can create some problems. Sometimes some points can be stuck on the limit or accumulate. So I like to do this, to multiply by 0.95, like this. Perfect. So now we have all these points reacting also in a fluid way, because they come from the first input. in the pop fluid solver. The thing is that we saw in this visual that we don't only have points, we also have these lines that most of you know as the proximity pop, but this proximity pop is only applied on the environment particle. The fluid shape, the main shape doesn't have proximity. So in order to do this, I'll create an attribute here on the environment particles that we're gonna call prox. Prox is gonna be 0 or 1 to say that we're gonna affect proximity pop or not, and 0 or 1, the uint type is enough. So here we say uint 1 and prox gonna be 1 on this aspect. It's because we want proximity to affect this point. But the thing is that we merge after. We merge this with this, and prox is not present here. It's not existing. So merge gonna also apply prox on this because we want, I forget the word, but it's not continuity, but we want to have a coherence in the attributes. So by default, prox here is 1 on this, but because we are merging also this one, it's gonna apply prox also on these points, but by default with a value of 0. We can observe it here. So we see that the environment points values is white, so 1, and the sphere inside is black, so it means that the prox value is 0. Perfect. So now we're gonna go here. After, I'm gonna use a delete pop, and I want to delete first the, let's say, the smoke inside. So I want to delete what's selected. Entities, we want to delete points. We only have points here. And in terms of attribute, I want to delete according to the prox attribute we created, but we don't see prox here. Because when we change the topology, when we add more points, when we change the initial topology, not the shape, but only the topology of our input, we need to reset, but also when we add a new attribute or delete an attribute, we need also to reset the simulation. So here in delete, we should now find the prox, like this. So I want to delete to keep only the environment particles. I want to delete when prox is equal to 0. So we already have the value 0, and now equals. So we see that we have only our environment particles. We can copy paste this node and here press invert, so we only get the fluid itself. And what I'm gonna do is that I'm gonna here connect a proximity. Maybe it's a bit big, like this. Maybe there is too much point. Why? Oh, I let the default value. Let's say 2000, maybe. Yeah, seems good. Sorry if I hope your computer didn't crash. I don't know. It should be okay, honestly. So yeah, sorry. Here you have to modify the number of points to put 2000. Oops. So yeah, it's pretty nice. Let's focus first on the environment particles, and then we're gonna focus on the main part, which is the fluid itself. So let's connect this proximity here. Okay. So we see here that the color initially is completely black. It's not really light, it's fake light, but there is color on the environment particles here only when there is movement. See? So in order to do this, we're gonna check a bit what attributes, custom attributes the Pop Fluid Solver is giving to us. So when we middle click mouse here, we see that we have P for the positions, we have age in frames, it's not in seconds, it's in frames, because here we enabled particles life. We have the color. I have to delete this, it's a mistake, it shouldn't be in this, in the Pop Fluid Solver. I have dead, which is UINT, so 0 or 1. If a point is dying in the current frame, the value of dead gonna be 1. There is the max age in frames. Normalized age, so instead of having the age between 0 and n frames, we're gonna have the normalized age, so the age between 0 and 1. It's like a ratio. And a PID that we're gonna see later, and a speed. So the procs, we created it before, so we're gonna use the speed now in order, as I said, to give color to the environment particles. So let's do it. So before the proximity, I'm gonna create a mass combine. And the thing is that I want to say it's black when it doesn't move, and it's white when it moves. We're gonna see the color after, thanks to a geo material and stuff, but I want black and white. I want to display white value when the speed is big, let's say. I'm gonna use the best software ever. So yeah, what I want to do is the speed is expressed on X, on Y, and on Z. So the speed can be in the positive, but also going in the negative, like this. Okay? But a speed going in the negative way doesn't mean that we want the color to be negative, because going in a negative way just means that the speed gonna go not in plus X but in minus X, but it's still intensity of speed. I want to still have a white color for this. So what we're gonna do first is that we're gonna take we're gonna do an absolute. It's a mathematical function. Is when we have a signal, so here it's positive, here it's negative, the absolute function gonna put all the negative value and put it in a positive way, in a symmetric way from the abscisse. I don't know what's the name in English. So if we do the absolute value of this function, it's gonna give us this. Okay? So here, for example, if I do the absolute value, it's gonna give us this. And here it's gonna give us this and this. And thanks to this, after, we're gonna do an average. An average, or also called length, the length function, which takes the 3 different channels and output them in one channel. So for here, for example, it's gonna give us something like this, this. Let's do it. Let's start with the. So we do absolute of the speed. Let's call it a speed. And let's add another operation as speed, and it's gonna be color RGB. So we see here that the points are white where there is movement. But in the post operation, we can check color RGB and increase the map to high. So yeah, we're gonna say map to high too. And here we're gonna connect instead of using the null, we're gonna connect the proximity to a geo now. And we're gonna put the color, this exactly same I have in my Instagram visual. So let's put 0.5, 0.51, like this. So we see now if we check also this, we're gonna have blue proximities only where there is the movement of the smoke. Okay, perfect. Also, what I want to do, I don't want only the lines of the proximity. I want also to use this in a separate geo, like this. So after the math combine, where the color are calculated according to the speed. And here in this geo, I'm gonna connect a line material, like this. And I'm gonna switch off this because we don't have lines, and switch on points. Perfect. And in terms of value, we're gonna put the same color as here. So let's select this color. Let's put it here, and this one here. And in terms of setup, we're gonna keep this like this. Because I know for the format we're gonna use in the render that it's the value that gonna match, let's say. Okay, so we can stop displaying this. So we have our different geos here. Perfect. So this environment is ready. What I want now, we're gonna switch off the display of these geos because we want a specific behavior on this fluid system. Because we see here that it's not only points, it looks like trails, but it's not only trails because it's a complete 3D shape. If we look at it here, we see that it's 3D. Okay. So yeah, in order to do this, I will reference to this video another tutorial I recently created, which is, this one. So you're gonna find the link in the description. So skin your trails or lines in general. So it's a free tutorial access. And here, if you click here, you have access to the example project if you are lazy to follow the tutorial. But I'm gonna explain a bit fast how to create the 3D, let's say, trails behind the movement of the points. Otherwise the tutorial will be so long. So if you really want to understand the theoretical aspect, technical aspect, please refer to this video. So I'm gonna put this down like this, and we're gonna work on this now. So what I want is to create trails. Okay, perfect. The thing is, it's weird. Even if we reduce this, okay, we see that it's behaving correctly, but there is all these straight lines here that are super weird. These straight lines appear because we have life enabled. So a point born moves in space, die, and then goes back to the initial position. By doing this, at the frame, between the two frames of dying and born, it's gonna create, obviously, a straight line. Is the initial goal, purpose, behavior of the trail. So the trail is processing according to the ID of the point. In the pop resolver, there is an option I created inspired from the particle pop. There is point ID reuse, don't reuse, etc. So here it's the same. You can or reuse the point IDs or don't reuse them. If you don't reuse them, there is an attribute called PID for point ID. And this ID allows us to, when a point is dying, to affect to this point another value of PID that doesn't existed before in the whole system. So when we go in the trail, you can match by attribute and here say PID. Okay, we need to increase the max number of line sweeps, I think. Why is it not working? Do I need to reset? No, really? I need to increase way more? Wow, okay. I don't really understand this. I have a lot of points, I'm sorry. I put 100k here. Let's say 10k. Okay. Let's stay in 10k here. I'm sorry. So 10k, and yeah, I don't really understand this, honestly. So we said that it's not only trails that we have. I want to create a whole structure on this trail. So we see that here we have a number of points per line sweep. Every line you see is a line sweep. So we have 7, but if we increase the length like this, we see that the max number is changing. Let's go back to this, even less, like this. So we're gonna put circles along the points of the line sweeps. Let's choose a radius of 0.005, let's say. And in terms of division, let's choose a triangle. So we're gonna copy pop like this. And first input here, second input here. And let's connect it here. So all I'm gonna do now is, again, reference to this tutorial. I'm not gonna explain everything. If you want deep explanations, please watch this. Anyway, so now we connect the circle. We see that all the triangles are in the same orientation and are not following the shape of the lines, because here we choose XY plane. So I'm gonna go to templates, and here template rotate to vector, and choose the speed attribute. We see now that the triangles are following the movement of the lines. What I want to do now is to create a skin pop, but the skin pop is skinning on all the primitives. So I'm gonna fix the number of points per line by using a line resample, like this. And here select divisions per line sweep. Perfect. And I'm gonna choose something like 16. Okay. So here, instead of skinning all the primitives, we're gonna skin groups of n primitives, because we know now that each line has a fixed number of points. Even if you modify the length of your trail, here it's gonna be still every time 16. So let's put back the try to 005, line resample 16, and let's take this parameter here and say that we skin every 1 plus number of line resample divisions. So we see that we have something way more interesting now. Let's increase the length of the trails. See, we have like kind of I don't know, like it looks like pastas. But I don't like the shading. I think we have to process the normals. I don't know if the skin by itself can process. No, it's weird. I think the skin should do this. So normal, and now we have our pastas. Okay, perfect. It's beautiful. So all of this is deeply explained in the tutorial, in the caption, concerning add skin to your trail. So now I want to modify the scale of the circle. So the scale of the circle is basically the radius according to where we are in the line. I want the line to be big thickness here, but zero thickness here. I want like kind of drops shapes. I want to try to increase the number of divisions because it's a bit ugly. To like 10. Well, it's a bit better. But if you increase the number of divisions here, you increase a lot. Like a lot the number of points here. I just don't know why. Here we have okay. Anyway, I'm sorry. Let's go back to 3 for now. So I want to, as I said, modify the scale according to where are the points in the line. So still, it's a reference to the tutorial I created, so I'm gonna go fast. Line strip, distance from start normalized, and we're gonna use a visual way to manage the scale. Thanks to a ramp top, connect it. Here select distance start normalized. And in terms of output attribute, we're gonna select point scale. But we don't need the RGB and A because point scale is float 1 by default in TouchDesigner, and it's a subject I don't really like. So we can do this. We can disable G, B, and A. So we're not gonna analyze the G, B, and A values here. Only the red. So yeah, and now we can, in the copy, enable in the template page the point scale. And we see that the scale is modified according to where are the points in the lines. I don't want this this shape. I'm gonna put the black here, something like this. Exactly. It's way better. I don't know what I was saying because my neighbors don't have internet anymore, so I gave them the password. Anyway, let's try to have a proper look here. Oof, yeah, we have to be careful with this. So it's pretty clean. Let's go back to 3. What I want to do now is I want to add colors to the trails. So just before the trail, I'm gonna like this. I'm gonna add again a lookup texture, again a ramp like this. Drag and drop the ramp on the node. Why is it still at? Oh no, it's okay. In here in the lookup, we're gonna select normalize age. So the age, the evolution of the age between 0 and 1. And we're gonna affect the color. Not enough component, ignoring input components. Okay. So we untick this to get rid of the warning, but honestly we don't care about the warning. And here I'm gonna choose a different aesthetic, like this. So we can see now that if I do this, the particles that are young, the color is on the left, and the particles that are old, their color is on the right, and it's evolving. So I'm gonna put this in the middle, like this, and I'm gonna put this in period of 0.2. I like this this effect, but we don't see it here because in the copy, by default, it copies this geometry on the points, so it keeps the attributes of this geometry. So we have to go in template attributes, use template point attributes, and here select color, like this. The thing I don't like is that when a particle is dying, I want the color to fade away, like to black, not to just stay in a white and blue process. So let's create again a lookup attribute, a lookup texture, sorry, a ramp top, and here we're gonna put full white, another full white here, and here we're gonna do this, and we're gonna call this, according again to normalize age, we're gonna call this fade color. And at the end of the, just before the copy, I'm gonna create a math mix where we're gonna multiply the color with the fade color. Maybe not color RGB, maybe just color like this. So we see that when the points are dying, the color is going to black progressively. If we do this, it's gonna be more obvious. See? So we can't see alpha in this geometry viewer, so it's going to black. Okay, I think now we are ready to render everything. In terms of behavior, we can hide everything like this. It's better for the performances. Let's go to a value of 0.001. In terms of the trail length, I'm gonna put 0.05. I'm gonna increase the number of points here to maybe 30k. Reset. Enable this and this, and now we have the fluid system working. In terms of behavior, we're gonna go into the custom parameters of the pop fluid solver. Here you can choose whatever you want. 1 on 20, 1 on 30 to have something faster. But for one, let's stay to 1 on 20. We're gonna put the viscosity of the water, which is this. So it's gonna the viscosity, basically, when you have like very low viscosity, it's gonna act like smoke, and if you have like high viscosity, it's gonna act like honey, for example. Let's increase the vortices. If we don't have vortices, it's gonna behave like this, like super smooth without vortices. But if you increase, you see a lot of little rotation twirls, like curling effect. So let's put this to 0.2. And here we are basically good. I maybe increase a bit. I'm gonna explain all of this in the next tutorial, like more technical. This one has to be more interactive and playful. So yeah, I think we are ready to render. So I want also, as we see in this that the fluid simulation is in the box. So we're gonna create this box. Okay. So to create this box, I'm gonna just copy this one, paste it here, and create a geo with a fong like this. Perfect. And also let's get rid of this and connect this to a geo also with the funk material. The thing is that, as we can see here, we see through the cube, and there is nothing on the top. So we're gonna delete two faces. It's not faces like primitives or quadrilaterals. We're gonna delete this quadrilateral here and this quadrilateral here. So here, let's see the primitive indices. Each primitive have an indices, same for the point or vertices. So we see here that we want to delete number 2 and number 5. So we're gonna add a delete pop, and in pattern we're gonna select 2 and 5. But it's not what we do, because here we are deleting index 2, index 5, but on the points we want to delete primitives. And as we see now, we have the shape we wanted here. So yeah, now let's we have everything. So we have geos 5, 2, 3, geo 4. Let's rename everything. So the first one is, let's call it box, not box, voxel vis for visualizer. This one is fluid. This one, after the proximity, gonna be environment particle prox, environment particle points. Yes, and here box. Perfect. Okay, so now we're gonna work on the render. The render I have in this is a bit particular because we are using render pass. The three key components here are render pass, the depth, and the bloom. And thanks to this, there is these like fake illuminations on the box, as if the fluid itself is creating light. And not only light, it's respecting the color of the light actually. Anyway, let's do it. So we're gonna create first a camera. We can hide everything here. Camera, I untick this. We can close this also. A light, I untick this also. And a render. We're gonna create transform. Here, put one comp over background color. I'm gonna do this, split the screen in two, and here select top viewer. In the render, I'm gonna choose, let's say, social networks resolution, like this. But I want to keep my workflow clean, so I'm gonna go right click here, display, and backdrop tops. So we're gonna only visualize on this panel. In terms of pixel format, I want 16. And with the camera, we're gonna go closer to this, like this. The thing is that I want the box to fill my render. I mean, not only the box, the whole fluid simulation itself. So we have the resolution, which is 1080 1920. So here, in the voxel grid init, in the size Y, we're gonna go to whoa, calm down. This is what happens when you modify these without initialize again. I'm gonna put 1920 divided by 1080. Reset. So we see now that the box, the the system, the environment is completely filling the resolution. You can affect these parameters dynamically to this if you want. Anyway, I'm a bit lazy. So now we're gonna move a little bit the light to something like this, maybe. And I'm gonna add shadows, soft shadows. Let's keep the same resolution here and here, and put 4096. It's not super clean. I don't know what's happening recently with the shadows in TouchDesigner, but there is definitely something weird. Yeah, all these things here are weird. We need to take a bit of distance. Okay. It's still not super clean. Maybe I know why. In the shadows we see that we have shadow caster. We can express what geos we want to cast shadows, so maybe we also don't want this. Okay, makes sense. We see the lines here are from this one, so we have to uncheck this from rendering. So yeah, it's way cleaner now. So what I want to do is to first separate, let's say, my different renders, because I'm gonna have different renders thanks to something called the render pass. In the first render, we're gonna render the fluid itself. The fluid itself is fluid, environment particle proximity, environment particle points. So here I'm gonna write fluid EP prox EP points. Okay, so here I render only this, and here I want only to render the geometry box. But we see that it's not rendering only the box. We have to clear the color buffer, and we see that the space where there is the particles, the fluid, is now alpha, it's transparent. We can go back to a normal render by doing this over this, like this. And in this way, we can process, post-render processing, the different geometries differently. So I don't want to add a bloom on this, I want to add a bloom only on the particles. In terms of parameter, we're gonna choose like pot 1, 1, 1, something like this. Yes. Bloom threshold. Okay. So it starts to look good. Perfect. I'm gonna maybe increase a little bit the high values thanks to a level. Here in range, we can decrease this in high parameter a little bit. Like this. Perfect. So we see that now we applied a bloom only on the particles and not on the box. By the way, I'm gonna fix this by zooming a bit the camera in, like this. Okay, nice. And I'm gonna use another render pass, but now with everything without light. So we're gonna use we have everything here, perfect. And I'm gonna use a depth map like this and a reference. We're gonna choose 8-bit fixed red. We only need one channel, we don't need so it's gonna create a mono texture rearranged from camera space, and here we're gonna put 2.4 1. Yeah, it's good like this. And after this, I like to, when the geometry is static and the camera is static, I like to normalize between 0 and 1 to have, I don't know, it depends. It's not mandatory to do this. What I want to do is to add like like a water environment. So I want like the depths to be a bit like a dark blue, and yeah, I want to do this. So I'm gonna here at the level, I'm gonna invert and multiply this by a constant with a blue value. Let's put this, but we see that even if we are multiplying this by a blue value, for example here, if we do this, it's getting blue, but not here, because if we look at the format of the texture, it's mono. So here let's choose 8-bit fixed. Yeah, perfect. And I want to multiply this like this. So this second input, this first input, like this. So we have this blue and a bit dark environment. It's a bit dark for now, but we're gonna fix this. Now we see that it starts to look good. I will add a null here, like this, and I want to multiply again the whole system, second input. No, not this one, I'm sorry, after the limit, by this. Okay, it's super dark. I don't really know why. Maybe I can reduce the specular here and put 1. It's really super dark. Maybe when we're gonna add more movement or more particle, it's gonna behave different. Here we have also 16-bit float, perfect. I don't know why it's so dark. I don't really understand why. Weird. Anyway, I'm gonna do something else. I'm gonna add a rectangle here. I'm gonna set resolution only, and we're gonna use a lima blur. The lima blur basically just say that it's gonna put a blur where there is a white value in the second input. Like this, we see that it's blurry here and not around. If we increase it, the thing is that, okay, you see the blur here? Anyway, I want to have blur only on the borders. So the rectangle, I'm gonna push the softness to 1, and we're gonna increase the size to something like this, and maybe invert this. No, I'm not sure about what I'm doing. Now we're gonna put this and do this. Okay, perfect. So now I'm setting the blur only on the corners, the borders, sorry. Now I want the fluid simulation to behave with my mouse instead of a noise. So I'm gonna use a mouse in. Okay, I'm gonna add a null. We can filter a little bit the variations of the mouse in with a filter chop. Put a width at 0.1, so it's keep reacting fast. And here in the transform, click on translate, press this to disable the noise. So the sphere gonna stay in the center. And here, perfect. Okay, the thing is that when I go on the Okay, let's start to increase the force. Maybe I want something higher. Here I put 1 on 120. Ah, okay. No, okay. Let's push too much. Okay, cool. Perfect. So we see here that when my mouse is here in my screen, I'm already in the border of the box. So I'm gonna use a math. Oops. After the filter only. A math multiply range 0.5. So the x gonna be no. I don't want the noise. Transform tx like this. Oh, it's still not good. I don't know what are the good values. Oh, it seems to be good. Okay, anyway. And we're gonna do the same for the y. When we are here, we are at the bottom, so I want to increase it. Ty. If we are here, let's increase again. Oh, we can increase a little bit. Okay, cool. So yeah, I think we finished the tutorial. So it looks good. Yeah, there is a lot of things you can modify, like the number of points here. Save your project, please, when you reach this point. So yeah, we can increase the number of points. And yeah, I don't really understand how is this bloom, like making as if the box itself is enlightened, but it's super beautiful. I love it. So yeah, there is a lot of things we can play with. So first, if you have a good computer, or even if you don't have a good computer, you can try to increase the resolution here. So save your project first, and let's put here 64. It's gonna behave like way more precisely, and the vortices and everything gonna be way more beautiful, as you can see. We can change, as I told you, the number of points here. So there is 100k. I'm gonna try to push to 1 million. I hope my computer... No, it doesn't like it. I stopped my bullshit. Okay, so 100k, it's enough, honestly. We can change the shape to have like a torus. We can change to have, I don't know, a line. Lines are a bit weird in a fluid way, honestly. Anyway, let's keep the sphere. You can change like the vorticity strength to have a lot of vorticities like this. You see all these curls and stuff, super beautiful. If there is too much, it can create speeds by itself and act in a super chaotic way. Anyway, we're gonna see this later, the buoyancy, the temperature and stuff. We're gonna see in the next tutorial. There is linear damping for the speed to goes down, because otherwise you can enter, especially with the vorticity, we can enter never-ending velocity system. So I'm gonna go back to 0.01. Limit speed, the force multiplier. So here we are pushing the fluid in this direction, but we can also propulse, let's say, the fluid like this, as you prefer. Obviously there is the different colors you can change. Let's choose something a bit more like this, and here change the font of this. beautiful. And yeah, I don't know what to do with the light because we don't really see. We see the shadows here in the fluid. We don't really see the shadows on the box, but in the fluid itself we see the shadows. Look, if I do this and disable the shadows, all of this is gonna go full white. I like to have these shadings. So yeah, super cool. I'm happy that I think the tutorial is gonna be a bit long, but I think it's a good first tutorial for approaching this pop fluid server in an interactive way. So obviously there is the mouse in, but you can use media pipe, Kinect, library to detect the position of the hand, of the head, whatever you want. We can also put our camera more in the system. And there is this funny effect. I mean, all the post-render effect is made to work only in the facing the system, like this. So it's not made to be seen from here, but still it's interesting. We can see it from under. Beautiful. And yeah, that's it. I really hope you enjoyed this tutorial. I'm really happy to share this with you because I wanted to create a fluid simulation since a long time. I mean, since I started TouchDesigner. So yeah, that's it for now, and I'm gonna put another tutorial very soon. See you, enjoy everything, enjoy life, bisous bisous, ciao.